All right, welcome back, guys. This is the woman who code Python. Less is more. How to code Python in one line. This is the intermediate session number 2. My name is Karen. I'm the moderator today, and here I'm with Poojita. She will be the presenter. So Poojita, here you go.
Thank you, Karen. Hello, good to see you all. I can see a lot of familiar names. Welcome. So I'll be your instructor for today. My name is Poojita Garg, and a little brief about me. So I am a research intern at Georgia Tech and IIT Roper. And here with Women Who Code Python, I serve as a track lead. So you can also connect with me on Twitter. Okay, so let's get on to today's agenda. So we will start with what is one-line coding and its benefits. And then without wasting any time, we'll just drop onto the live coding session. And then we'll have some time for Q&As. Okay, so let's start with what is actually one-line coding and what are its benefits. So one-line coding refers to writing one or minimal lines of code to perform repetitive functions or processes. So some of its popular benefits are that it is easier to read and maintain the code and debug it. Also, this reduces local memory, complexity, execution time, and confusion, especially when the script is co-developed with others. So, many times we are co-developing a code. So it is very helpful when we have a co-developer. Okay, so let's get onto our live coding session and let's get on to our Colab notebook. So Emma, please drop the link for the Colab notebook. Okay, so you all can find the Colab notebook here in the chat. What I would like to do, what I would like you to do is that you can go to File here and save a copy in Drive. So you can have your own personal copy and you can practice it anytime you want. So just go to File here and save a copy. So here a copy of it will be saved onto your Drive. Okay, so let's start our today's session. So we'll start a session on the note of Zen of Python. So a Pythoner named Tim Peters once wrote 19 principles stating how one can write beautiful and clean code with Python, which came to be known as Zen of Python. So the guidelines motivate the programmers to write simple, readable, and clean code. So you can find these 19 principles by using this import this command, and by running it, you'll get the whole Zen of Python. So some of the principles which are particularly important for us in this today's session are the first one, which is beautiful is better than ugly. So obviously beautiful code is always better than a haphazarded code. And the second one is this one, that readability counts. So one-liner Python codes help us to increase our readability of the code. Hence, it is really helpful when we are co-developing it with another person. So let's kickstart this session with a Kickstarter example. So let's talk about search engines. So search engines rank textual information according to its relevance to a user query, right? Just like Google does. So to accomplish this, search engines analyze the content of the text to be searched. So all the text consists of words, but some of the words provide a lot of information, while some don't. So the words among which don't provide us information are like is, the, as, or. So a general rule is that any word which has length less than 3 or equal to 3, so they are not really providing us a lot of information. So the search engines, they tend to avoid such words and just filter out those words. So what we'll do is that we try to filter out such words using one-liner Python code. So in this example, you can see that we have a text here, and we want to basically see what all words have length more than 3, and just list them up so that they are the ones where we can analyze further. So let's look onto our one-liner code here. So this consists of 2 list comprehensions. Now, all those who have attended our previous sessions, I have talked about list comprehensions before. So list comprehensions are essentially the code which is written in square brackets. So they're basically used to create a list. So here in this code, we are using 2 lists. So we are using basically a nested kind of a list. So we'll talk about the inner list first. So the inner list comprehension, this expression, uses the string.split function. So first of all, what the split do is that the split function splits the string into whatever the character is given inside this function. So if nothing is given, that means it will split to space. So we have a line here, and this line, it will be split into words by the space character. So we're just saying that all those words which are represented by X in the line.split, and all those which have length greater than 3 should come forward, should be filtered out, right? Now, what about the outer list comprehension? So the outer one is basically giving us the line. So what is the line is that in all this text, we are dividing the text by the new line character. So we'll take one line at a time, and we'll divide it into words, and we'll see all those words which have length of more than 3, and we'll just make return it in form of a list. So when we run this, so this is what our result would look like. So this will be a list of lists. So each with a list inside would have words which are more than 3, and each of this list will correspond to one line of this text. So this is how all these words will be more than 3, and this will how a search engine would actually take out the words which are of importance. So just let me know if everything's going great with a thumbs up or a P, or a B, and if nothing's going great or there's some confusion, then please give a P in the chat and let me know what I can repeat or something I can help you with. Okay, that's great. Okay, so the first function which we are going to look today into is our lambda function. So in today's session, we have planned a lot of exciting functions, which are really cool to use, but are very, very important as well. I mean, they are the base of when you are writing one-liner code. So they are the base which will form your, which will help you along the way. So the first and the very important function here is the lambda functions. So we have generally used, functions by defining them using the def keyword. So these lambda functions are basically the anonymous functions. So why they're anonymous is that because they don't have a name. So all the other functions, we give them a name, but these lambda functions, we don't give them actually a name. So they're just called lambda functions. Now, where they're used is that these lambda functions are used for small functions, which you have to perform some calculations, some small calculations. Let's see what the syntax of it looks like. So it starts with the lambda keyword. It has some arguments and a colon and then an expression. So what it will do is that it can have any number of arguments here, then a colon, and then the expression which is after the colon. This will be evaluated and the result would be returned. But the caveat is that it can only be one expression per lambda function. So there can be many arguments, but only one expression. Let's look into it. Okay, so this is a simple code to add 10 to any argument and return the result. So this is how we are going to write it using the def keyword and defining the function and then calling it. So this is def function A, return A plus 10, then print, and we're just calling inside the print statement the function func. Okay, so This is how it's a like we'll do in a multi-line code. But let's see how we can reduce all this work into just single line using the lambda function. So here I'm using the keyword lambda. I'm assigning the argument, which is like a, and the colon, and then the expression which needs to be evaluated, which in this case is a plus 10. And I'm putting all this into x. So the x will essentially have our result, which will be after evaluating the lambda function. Then I'm calling, like I'm using x, and I'm passing the parameter inside it, 5. So this 5 will basically be a here. So let's just run them and see what results we get. Okay, so you can see that 5 plus 10 is 15. Here also we have the 15, and here also we are having 15. So this is again basically the logic behind the same. We are just reducing the number of lines using the lambda function. Okay, so let's practice it. Let's practice a couple of times how to use a lambda function. So the syntax here is very important. So just make sure you use the exact syntax. Let's see that. Let's summarize the arguments A, B, and C and return the result. So let's see how we can do that. Okay. So let's say result equals lambda. Now here we need to summarize A, B, and C. That means we have 3 arguments, A, comma, B, comma, C, then a colon, and then we have to return the result. So the sum of all these 3 arguments. So A plus B plus C. Okay. Okay. Now let's print our result. Now we have to pass the arguments here. Let's see, let's just pass simple one. And here we go. So we have 9. So this is how we are using lambda with 3 arguments. Let's practice another one and see how we can square a number using lambda functions. So let's say result 2. And again, the keyword lambda. Now here, when we need a square of a number, so we'll just pass single number. So that's just A colon, and here A into A, so the square. Okay. Now let's print it. And let's just pass like say 5. So here we get the square, which is 25. Let's practice it one more time and see how we can find the maximum of 2 numbers. Let's say result 3 equals lambda. Now, because we want to find the maximum of 2 numbers, so definitely our arguments here will be 2. So let's say A and B. What we are going to return is we are going to return A if A is greater than B, else B. So this is how we are also using if and else in one line. So in previous sessions, I've explained how to use if and else statement in one line. So here we are making use of it. Okay, let's print our result 3. Let's pass few parameters. Let's say 30 and 35. Okay, so we get the maximum of the 2, which is 35. So I hope now lambda functions would be very clear. Just let us know with a thumbs up in the chat if lambda function is clear, and then we can move on to the next functions, or let me know any doubts if you have in the chat. Oh, great, guys. You are all amazing. So let's move on to our next function. So after lambda function, we look into what's map functions. So a map function returns a map of an object, a map object, which is an iterator of the results after applying the given function to each item of a given iterable. So an iterable can be anything like a list, tuples, or set, or dictionaries, or anything. The syntax for the map function is map. Then you have two arguments here, a function and an iterable. So this will apply this function to every element of this iterable. So function can be anything what you want the items to process that logic, and iterable is any iterable which you want to be mapped. And this returns an iterable also. It returns a list or an iterable again. Let's see an example for map function. So let's double the number. So let's see a function which can double the number. So this here we have defined an addition function, which is just doubling the number. We have this numbers list. We're just taking a very small list to demonstrate here. And here's the result. So we're using the map function. This addition is our function which needs to be performed on each element of this numbers iterable. Then we are just printing it in a form of a list. Let's run it and see. So now each element 1, 2, 3, 4 is doubled to 2, 4, 6, 8. So map will actually perform the addition or whatever the function you have given into the map to each element of the iterable. Now let's see how map functions are used with Lambda. So like this combination is very popular while writing one-liner codes. So let's look into it. Let's see one example. Now the same example here, we will do it using Lambda as well as map. So again, we have like initialized numbers as an iterable 1, 2, 3, 4. Now we are again using a result to get the mapped list. So let's say map function, and then we are using, instead of actually defining the function explicitly and then calling it inside the map function, we are using the Lambda function and we're defining it at the place of where the function needs to be called in the map function. So we're using Lambda argument x, which will return x plus x. And then here we are passing the iterable numbers. And then again, we are printing it. Let's see. Okay, so we have got the same result. So this is very helpful. Everything is just written in one line, and it's really helpful when we are writing like bigger functions or using large number of elements of the iterable when we are working with a bigger code. So let's practice this combination of map function and our Lambda function. So this example is basically we are checking a substring in a string. So let's check whether the string x contains a substring y by using the expression y in x. So what we should return is that we should return a true if that substring is contained in the the string, and false if it's not containing the string. So we're using the data here, which is the text data set, which is the list of strings. And now we have to see whether anonymous is present. This anonymous is present in, like, we'll check for each element of this list text. Let's say our result. And now we have to use the map function. So let's say map function. And now here we have to define the function. So we'll use Lambda function for that. So say Lambda. Now this will have one argument, which is the string. It should return. Let's say we'll return it in form of tuples. So let's say return true, comma s. So we should also know the for what it is returning true. So let's say in a form of tuple, true, comma s. If our substring, which is anonymous, in s. So s is the string we are checking for, anonymous is the substring we are checking. So if this is present in s, then return true, comma s, else return false, comma s. And then we are passing our iterable, which is text here. Let's print list of our result. Okay, so here we have the list. So it has tuples. So it will check for the first string. This is lambda functions and anonymous functions, and it is returning that true because our anonymous is present. Then in the second, also it is checking for anonymous, it is present, so it's returning true. But in the third element of this list, it's not present, so it has returned false. So before moving ahead, please let me know if map functions and lambda functions are clear to everyone. And if not, then please let me know any questions if you have. Okay, great, everyone. Okay, so let's look into what's filter functions are. So filter function is another type of function. Here, it will basically filter the given sequence with the help of a function that tests each element in the sequence to be true or not. So in the map function, it was again testing for each element of the sequence, but it was not, so in filter function, the difference is that it will return just true or false. So that means that it will filter out the ones where the function is returning true. So you'll get only those elements of the sequence for which the function returned true. Let's see what the syntax is. The syntax is, it's very similar to the map function. We are using a function parameter where we'll call or define the function. Then we're using an iterable, which is sequence. And this will return again an iterator that is already filtered. So it will return you a filtered iterable. Let's look into it. Let's say that you have a list of English alphabets and you want to find those which are vowels in that list. So first we are defining a function to calculate how the logic behind how to calculate variables. So we are defining letters and a list of vowels, and we are saying if that argument is in this list, then return true, else return false. This is our sequence here, which we are testing. Let's use filter function. So this is the filtered result, and the filter function is using that the fun function which we have defined and the sequence. And so this will, let's see what it will return. Okay, so this has returned E and I. So in the sequence, E and I were the vowels which were present, so it returned as the filtered result. Okay. So now let's see how to use filter with lambda functions. So our methodology will be very similar to what we did in the map functions. We will, instead of actually explicitly defining the function, we would use a lambda function instead in the place of function, and then we'll call it for some sequence, and we'll get the filtered results. Okay, let's take a good example here, which is of finding all prime numbers. So let's see that we have a range, we have given a range of 2 to 13, and we want to find all the prime numbers. We'll use the filter function, but in addition to that, we'll make use of another Python function, which is all function. So what this all function does is that it will return true if all items of the iterable are true. Just like, sometimes we use AND gate, if you are familiar with that. So it will return true only if all of the elements of the iterable are returning true. So just let me, brief you about how what the logic behind our code would be. So we will, calculate all prime numbers in a way that we'll check for our list for each element. Let's say 5. Now we're checking if 5 is a prime or not. We'll use all the numbers from 2 to that number. So we'll use 2, 3, and 4. We'll use the modulo division. We'll see if any of these numbers, when divides 5, if the remainder is not equal to 0, that means it is not completely dividing that number. So that means it is a prime number. So let's see how we are coding it. So we are using, again, our lambda function. We are saying that x is an argument, and then this is the expression. Now inside our expression, we are using all function. So that means if every element of this function, the parameter of all is like true, then only it will return a true. We are using x and we are using modulo division y by y, and if not equal to 0 for y in range of 2 to x. So we're using from 2 to that number, all those are y. We are checking it, we are modulo dividing it by x, and then we are checking if it is not equal to 0, that means it is, that it is a prime number. So this is what the result we have is that from 2 to 13, 2, 3, 5, 7, and 11 are all the prime numbers. Okay, so let's practice some simple problems just to get on hands-on on our filter and lambda functions. So let's say that we have this list of sequence, and we want to find, first we'll find the odd numbers, all the odd numbers in the list using the filter function, and then we'll find all the even numbers. Okay, so let's say, again, let's say our result is filter. Okay, and now we have to define our function. So we are using lambda functions for that, lambda. Okay, let's say x. Now we will say x if x when divided by 2 is not giving us, is not equal to 0. Then we are saying xy. Oh, I'm so sorry. So here it should not be x, it should be true, because the filter function works on true and false. So if it gets a true, it will return that in a list automatically. Okay, so here it will be true, else it will be a false. And here our sequence, which is sequence here. Let's print in a list form our result. Okay, so here we have in this sequence all the odd numbers, which is 1, 3, 5, and 30. This is returned. So just make sure that we are, while using filter, you are just returning true or false. So it will automatically pick the ones which returns true. Let's again try it for, finding out all the even numbers. So let's say result 2 equals filter lambda x true if x when modulo divided by 2 is giving us 0, else just return false. Print, let's print it in form of result. Oh, oops, my bad. Here I just made a typo. Oh, we forgot to pass our iterable. Now what's the issue? Oh, yeah, lambda x. That should work, it should work. Yes, see, it's working, finally. So it's 0 to 8, all the even numbers we are like filtering out from our sequence. Okay, so after the filter function, let's get onto our reduce functions. So like in the previous session, I briefly talked about the reduce functions. Let's talk about it again very briefly. So reduce functions, they are applied on 2 arguments cumulatively to the items of an iterable from left to right, so as to reduce the whole iterable to a single value. So it will be more clear when we'll get onto the example, but let's see what the syntax is. So this reduce function is from our Python module, which is func tools. And the syntax is that we use a function, we use an iterable here, and we also use an initializer. So this initializer is an optional parameter, and it is placed before the items of the iterable in calculation and serves as the default when the iterable is empty. So if the initializer is not given and the iterable contains only one item, the first item is returned. So it will be more clear when we see how the example works. So first of all, let's import it from the func tools module. So from func tools import reduce, and so we'll define we are defining a multi function to multiply two numbers. This is returning just x into y. This is our list, and we are using a reduce function. So here is the function multi, here's the list. So what this is doing is that it will take two elements at one time. It will multiply them or perform the function given. And this way it will iterate over the whole list or the whole iterable and give us a cumulative result at the end. So this is essentially multiplication of all the elements of this list. Let's see how we can use this reduce function with lambda functions. So again, our concept would be the same, that instead of defining a function explicitly, we'll use lambda function instead. So we'll import reduce. This is the list. And again, we are using reduce function. Here lambda, we are having two arguments, x and y, returning the multiplication of them. And we have a list. So let's print it. It's giving us the same result. Let's practice it. For practice, let's say that we have to find the maximum of two numbers using not maximum of two numbers, but maximum of the numbers present in the list, like all the numbers, what's the maximum of them, using this reduce function and lambda function. So this is our list for now. And let's say, so our result max would be, so we'll use the reduce function. We'll define a lambda. So for max, we'll use two arguments, x and y, a colon, and then the expression. So return x if x is greater than y, else return y. And then our iterable, which is list here. Let's print our result max. Okay, so 6 is among the maximum, is the maximum actually in the list. So it is just returning as 6. Okay, so before going on to our next set of functions, let me know with the B if everything's going great, or if there are any doubts, let me know in the chat. Okay, great, guys. Okay, so let's see how to read and write a file. So just a moment. Before that, let me just upload a file here. So in Colab, what you do is to upload a file, you create a file on your desktop and you just drop here in the files, and this will be imported. So this is my just a sample file here, myfile.txt, and this is imported here. So now we can use it anywhere we want. Okay, so after this, let's see how to read a file in one line and how to write a file in one line. We'll start with, again, seeing what a multi-line code looks like for reading a file. So, so we start with initializing a variable with a file name. So here, the name of my file is myfile.txt. So I'm using file name variable for that. I'm using another variable to initialize open the file name. So I'm using open function with the file name. So it will open our file. I am initializing li as an empty list. So there we will like use it for reading the elements of our list of a file. Then I'm using the for loop here on line in F. So for every line in F, which is our file, I will append to this empty list all those lines. Okay, so I'm reading file line by line. For that, I'm also using a strip function here. So the strip function, the string.strip function, removes all the leading and trailing white spaces, including all the new line characters and the tabular characters. Now I'm printing it, and at the end, I'm closing the file. Okay, so my file contains just 2 lines saying hello Pythoners and hello world. So this has printed in form of a list here, like we did that in li append. And this is what the contents of my file look like. So as you can see that it's a cumbersome job, right? It's so many things and so many, it's taking us so much space, and we have to remember all of these, like when to close the file and other stuff. So let's see how we can do everything in one line. So we'll look into 2 ways to do that. So the way one would be using the with keyword. So this is very interesting keyword. So the with environment makes sure that there are no side effects of opening files. So this thing which you did here, f.close, sometimes we tend to forget it to close the file. So with this with keyword, we should not worry about that. So the with environment takes care of those that there should be no side effects for opening files. So how we do this is that with we use the open the open function and then the file name. So with open this file as f is a variable here, and we use the colon. So this is the syntax for this. We are using li to get the list of all the lines present in our file, and then here again we are using the list comprehension. So defining using that for loop and stuff in just one line. So using list comprehension line.rstrip. So here you can do also like single strip, or so rstrip basically is that all the right trailing trailing the spaces and new line characters would be removed. So for line in F, so each line in F, which is our file, it should give us li. So this is again li is like is a all the lines of present in our text would be returned in form of a list li. It's exactly the same. Let's see the way two. Way two is without using the with, we can also do everything in a list comprehension if that's preferable. So let's say that li is again our list, which needs to be returned. We're using the square brackets as it is. We are saying that line dot strip for line in open my file.txt. So this is like a more simpler version of it. But here, because we are not using with, so we'll have to do an f.close at the end, and then we are printing the li. So this is the result which it will return. So the results is all the same in all the 3 cases, but it's just the way we want to code it. Okay, so let's see. Okay, so let me know if this reading the file is like all the 3 codes are clear in the chat before we move on. Yeah, yeah, sure. Which one do you want me to repeat? From the multi-line one or the way 1 or way 2? One line or one? Okay, so I'll repeat both of them. Okay, so in one line code, if you understood all the functions associated with reading a file here, then we are just using these in 2 different formats. Let's look into what way 1 looks like. So in way one, we are using a with keyword. So this is a special keyword used for reading files. So with keyword, so this is whole syntax, so we have to remember as it is. So using the with keyword at the starting. So with open, you're using this function, the file name here in this open function as f. So you are opening this file as this variable. And then the syntax says that you have to write a colon here. So you're writing a colon. And then you want the result to be in li list, right? So li equals, now here is the list comprehension where you are saying that l line dot strip for line in f. So here, like we said, that for every line, for line in f, here we are using it in form of a list comprehension. So we are essentially giving it what it should return. So it should return a line dot strip for line in f. So everything this is present in li. Then we are just printing li. And here's the result. Whereas in way 2, we are not using this with keyword, and we are using everything in a single list comprehension. Let's see how it is done. Again, we're using li for returning the result. Everything in the list comprehension, so everything in square brackets. Again, what we want to return is we want to return each line of the file. So line dot strip for line in. Now mentioning here f as a variable where we are assigning f to be open that file. We are removing all those steps and we are just saying that, okay, for line in, open this file. So we are removing that f variable here in this one. So this is more concise. Then at the end, we are closing our file and then printing printing li, which will contain our result. So, so this will return again the same thing. Okay, great, Pooja, great. Okay, now let's get on to writing a file in one line. So this was reading. Now let's see how we can write the file in one line. Now in the multi-line fashion, what the functions which are involved in writing in a file are, like, first of all, again, we have to open it. But here, while writing, we have to mention the way we want to open a file with. So here we are mentioning the format, which is A. So A means append. So we have all different formats, append, write only, and other things, which will, in some functions, it will overwrite the file. In some, we can, have other, we can give other permissions. So here we are appending the file. So we are not overwriting the file, but we are just appending a new line with the previous lines. F.write, just a small thing, I'm writing hi. So write function is essentially to do that. Then we are closing the file. So this will, write that in a file. So we can check this by, again, reading it. So let's use the above function only to read it. Now, after reading it, we have this hi function here. Sorry, the hi statement here. So this function has basically, has wrote in our this file. Now this everything could be concisely written in one line. Again, we are using the with keyword here. So with open, it's very similar to the read one. So for write, we say with open the file name, the mode which we want to open it with as f, again the variable f, then the colon, and then our write function. So f.write. So this time let's write that this has been written using one line code. So let's write the string. Okay, so this will not return us something, but this has written it, and then when we read the file again, this is appended to our file. So this has been written using one line code. This has been appended to our file. Okay, so we have a doubt here. So Kanksha asked that in way 2 of reading, why did we use the variable f to close the file? Oh yeah, I think I must have used the one before that. We can, yeah, because we are not using the f f variable inside it. So we can, yes, we can always skip this. Yeah. Thank you, Kanksha, for pointing it out. Yes, we should skip that. But usually it's a good practice that we use a variable and then we can close it. So, but in this case, the way this code is, we have used this code, so we have kind of concised everything without using other variables. So in this way, we can skip that. But otherwise, we should do that. Okay. So I hope everything regarding the read and write is clear now. So let's jump on to our next, and this would be our last function part of this session. So we'll see what generator expressions are. So we've talked a lot about list comprehensions. Let's see a very parallel version of that, which is generator expressions. So generator expressions work exactly like list comprehensions, but without creating an actual list in the memory. So the numbers are created on the fly without storing them explicitly in a list. So generator expressions are best used if list is an intermediary. So let's see, we'll just talk about generator expressions using examples. But before that, let's compare it with list comprehension. Okay, so in terms of syntax, the generator expressions use circular brackets for in syntax, and in list comprehension we use the square brackets. So everything is same, the code is same, just the syntax is different. And the other thing, memory. So the memory it takes when we use the generator expressions and the list comprehension, so they are different. So let's see how. So generator expression is lazy. That means it creates a single element based on request. So it loads only one element to the memory whenever and wherever it's required. A list comprehension, on the other hand, is eager, and it creates all the elements right away and loads all of them into the memory. So the caveat here is that once a generator expression has been consumed, it cannot be restarted or reused. So it's best to use generator expressions when we essentially don't want the output in form of a list, or we don't need a list, but we are just using a list as an intermediary, and we want the elements of a list. Let's see just how we can, in syntax, how do we write generator expression and how do we write list comprehension. Let's start with the list comprehension. So this is in how we write a list comprehension. So this is in square brackets. The result is hello 3 times. We're just saying that hello for I in range 3. So we want hello to be in a list 3 times. So this is the list comprehension. If we use the same as a generator expression, then we have to change its syntax from square brackets to the circular brackets. And let's print that. So the generator expression, when if casted in a list, it will look same. But if we are not casting it in a list and we are just printing generator expression, this will give us a generator object which is present at this memory location. So it will not return the whole list. Okay, so just to see where our list comprehension should be used, or where the generator expression should be used, let's use it with an example of sum of squares of the first 20 numbers. So let's do by both the methods. Let's see what a list comprehension gives us and what a generator expression gives us. So we have to essentially we have to calculate the sum of squares of first 20 numbers. So list comp sum, let's say. So this is equal to, okay, let's see list comp and then sum will calculate it. So in this, we are calculating the squares for x in range first 20. So let's say range 20. Now we'll use the sum function. sum function and we'll pass this list. Now let's print it. Okay, so this is the sum which we have got of all the squares of first 20 numbers. Now let's do that using generated expression. Generated expression, we'll use circular brackets. $20. Now we'll use our sum function. Okay, so this is also returning us the same. It should return the same. So it functions exactly the same. The difference is we saw the difference in syntax. Now let's see what at the behind the scenes the differences. Let's see that using comparing their memory sizes. Okay, so it's now you have seen that it is returning exactly the same. So for comparing their memory sizes, we'll use the function get size of, and that is present in imports sys module. So let's compare the sizes. Let's print list comp size. So here we'll say sys dot get size of. Okay. And in second, we'll print okay. So this is how our size goes. The list comp size, it's taking 272, and the generator expression size is just 128. So the list comprehension is taking more amount of memory, and your generator expression is obviously taking very less. Now the difference will be more significant if we take take a range of like a greater one, like say 100. When we do that, now let's see. So here again, the list comprehension size, it's taking 920, and the generated expression is again taking 120. So this is a huge difference, right, in memory. So to save the memory when our list is just an intermediary. So here our purpose was not to get the list, but to get the sum of all those elements. So in these cases, you should use a generated expression rather than a list comprehension to save memory. So hope that's clear to all. And let's wrap up today's session with a cool example again. It's like I love such examples which are really associated with real world. So let's say that you work in law enforcement of the US Department of Labor and finding all the companies that pay below minimum wage so you can initiate further investigations. Right, so you have a list of companies here and list of their employees and their salary, their wages, and you have to find out all those companies who are giving their employees less than the minimum wage. So before going on to the code, let's talk about another Python function, which is any, which we will be using in this example here. So like we discussed about the all function in the previous example. So we'll use any function. So this any function takes an iterable such as a list and returns true if at least one of the element of the iterable evaluates to be true. So in all function, it was that if all the elements evaluate to be true, then only it will return true. But in any function, if any one of the element of the list is returning true, the any function will give us a true result. Okay. So let's look into this. So our data is basically a dictionary. So a dictionary of dictionaries, and which is storing the hourly wage of company employees. So you want to extract a list of companies paying below your state's minimum wage. Let's say it's $9 for at least one employee. Even if it's one employee who is being paid less than 9, we want to, fetch that company. So this is the company's data set. Now let's look into one-liner code. Let's go through our one-liner code once, and then I'll explain what it does. So in this, we are using both the list comprehension and generator expression. So here you can see that we are using the list comprehension out as the outer expression, because at the we want the result to be a list of all this. But you're using a generator expression inside because there it is being used as an intermediate. Let's start from our expression, which is inside. So here we are calculating, we are using any function, and inside it we are saying that if y is less than 9, that and for y in companies of x dot values. So for this you should need a little knowledge about how dictionaries work. So this values is a dictionary function which will give us the values. So these are basically, dictionary has a key value pair, right? So it's the Bob is a key here and 28 is its value. So we are checking y for all the values. So we are checking for all the hourly wages here. For companies, which is our main dictionary. So for companies X is here this company. So it's the cool company or the cheap company or the so-so company. So this X is that, right? So the company's X dot values. So we're checking y for all these values. If y is less than 9, even for one, which is taken care of by the any function, then you want to return it. Now coming to the outer list comprehension. So we are saying that X for X in companies. So for this X here is this company. So is it the cool company, cheap company, or the so-so company? So X for X in companies, if this any is true. Okay, so when the any returns true, you want to print that company and all that in form of a list. Let's print it and let's find out what we get. Okay, so we get the result as cheap company and so-so company. So the cheap company here is paying their employees less than 9, and also the so-so company has one employee which is being paid less than 9. So even at 1, any will take care of that and will return a true. So here, so I hope this example is clear. Just let me know if this is clear in the chat with a B or with a thumbs up. Okay, great, everyone. Great job. So this brings us to the end of today's session. And, we have learned a lot of new things in this session. So let's get back to Karen and
Yes.
Yeah.
Thank you. I truly think Poojita done amazing job. Like she could explain like complicated stuff that not easy. Like she can explain it step by step very thoroughly. Like, and I'm a programmer myself, and she done like 10 times better than me. I'm truly so hopefully you guys like learn a lot from Poojita as well. I think they're interested in seeing the I think one of Celia is interested in seeing the system function where you can you see the amount of time again. I found it amazing as well. So maybe while we are waiting for everyone or any last minute questions, we can take a look at the amazing code again. It is so powerful and useful.
Yeah, absolutely, Karen. So here's the sys function again, the sys module again. So we're using the get size of function of the sys module. So we're calling it as sys.get size of, and we're just passing our list comprehension, which we created here, and a generated expression, which we created here. and we're just checking the sizes of it. So this is a way to do that, and we are finding out what the memory size is, like what they are, how much memory size they are taking. And as we increase our range, whatever we increase, so this difference will get more and more significant. So right now if it's 100, so it's giving us 920, and generated expression will give us the same size in all the cases. Why? Because it, as I explained it here, it's a lazy function. So what it will do is that it will create only a single element based on request. So internally, it is not creating the whole list at the same time and storing it in the memory and using that much memory. Because so that's why it is essential to use it whenever your list is intermediary in your code. Hope that clears that. That's
Yes. Yay. It's good. So thank you, Gita. Anyone has any other questions? Just a little heads up for the next section, which highly related to what Poojita has taught. So the November 20th, November 30th, it will be the last session of this one-line coding series. It will be advanced session. Just a little heads up, it won't be anything new to introduce. Instead, we will be doing like a practice example, like Poojita has always demonstrate at the end of the section. We'll be doing some case study to all the things we learned since from the beginner level to like up to like today. So a lot of mix and match. So because the reason doing this is when things are mixed together, it could be very complicated, even though like if you separate each of them, it makes sense to you. So I would strongly suggest take a look at Poojita's code again. I really think she explained it really well. So like take a look again, and then I will post, let me get you guys the GitHub repo. So all the works, it can be found on the Women in Code GitHub repo, including Poojita's amazing work. So just feel free to go through them. And if you have any questions, feel free to reach out to Poojita or me on the Slack channel. And we will see you guys in 2 weeks.